Alright, students, today we'll be looking at LHopital rules, which is a rule that shows us how to find limits, especially of a rational expression. And rational expression means that their numerator is a function, denominator is another function. We can use LHopital rules to find the limits of these algebraically, in other words, without using a calculator. Now, we begin by learning how to classify whether or not each of these problems are considered to be indeterminate form. So a limit is considered to be, or considered to have indeterminate form when direct substitution yields 0 over 0. Let me show you what I mean. So let's talk about what is meant by indeterminate form. Say if we have the limit of x approaches 2 of x minus 2 over x squared minus 4. If I were to evaluate this limit using direct substitution, I would get, I would replace x in the numerator with 2. And then if I replace that with 2 and square, I would get 4. And so direct substitution yields 0 over 0. If this happens, we consider this problem to be, or to satisfy, indeterminate form. All right. Again, in order to use LHopital rules, you need to check and make sure that the problem satisfies indeterminate form. Now, once it satisfies indeterminate form, then LHopital says, and by the way, LHopital has been around for a while, and he came up with this rule that allows us to find the limit without graphing. And he said that if the limit as x approaches a number of the quotient of two functions, direct substitution, if we do direct substitution, if we get, fa over g of a, and if that happens to equal to 0 over 0, then it satisfies the indeterminate form, which means that if that was the case, then he said that the limit, or that limit, will be equal to the limit of the derivative of f over the derivative of g. All right. And then all you have to do is plug a in for f, and then plug a in for g to find your answer. That's all. That's it. Now, if this happens to be 0 over 0, then that means that it's once again indeterminate form, and therefore you would have to take a second derivative and then do direct substitution. That's basically what LHopital says, and that's how we are able to use his rule to find these limits. Because of timing, I don't have a lot of time to show you or prove to you how it works, but if you want to, let me know and I can do it in class for you. Okay, so we now have a technique to find these limits without graphing. We can do it algebraically. So first, what we want to do is we want to check for indeterminate form. Do these problem falls into indeterminate form? By looking at this problem, if I were to substitute x with 0, then I'm going to get 0 over 0, because sine of 0 is 0. Sine of 0 is 0, and 0 is 0. So 0 over 0, guess what? It falls into indeterminate form. So by LHopital, so you can make a note, indeterminate form. Okay. By LHopital, I know that this limit is equal to the limit of the derivative of the numerator, which is gonna be 5 cosine of 5x, okay, over the derivative of the denominator, which is 1. The derivative of x is 1, okay? And then we go ahead and we plug 0 in. By plugging 0 in, I get cosine of 5 times 0 over 1. And cosine of 5 times 0 is cosine of 0, and cosine of 0 is equal to 1, and that's why I get 5 over 1, which equals to 5. So the limit of this expression is equal to 5. LHopital allows us to find that limit quickly without doing a lot of work. Okay, so if you need help or need further explanation, maybe watch this part again on what is LHopital rule and when we can use LHopital rules. Let's do another one, but before you apply LHopital rule, make sure you check and see whether or not the problem falls in the indeterminate form. So check for indeterminate by doing direct substitution. If I plug 1 in there, I'm going to get 1 minus 1, which is 0. If I plug 1 in here, I'm going to get ln of 1, which is 0, minus. If I plug 1 in here, I'm going to get sine of pi, and sine of pi is 0. So guess what? This falls into indeterminate form. So by LHopital, he said that this limit is equal to the limit of the derivative of the numerator, which is 1, because the derivative of t is 1. The derivative of 1 is 0. Over the derivative of the denominator. Now, the derivative of ln of t is 1 over t. The derivative of sine of pi t is going to be minus pi. Sine is cosine. Cosine of pi t. Okay? And I'm going to be plugging 1 into here. 1 over 1, because if you plug 1 in here, you get 1. Minus, if we replace t with 1, I'm going to get cosine of pi. And cosine of pi is going to be negative 1. So I have pi times negative 1, which equals to 1 over 1 plus pi. That is the limit of this problem. Okay, thanks to LHopital, we can easily find this limit by just using his rules. Okay. By the way, the derivative of sine earlier should have been sine is cosine. Cosine. Oh, okay. Oh, okay. Very good. So remember, it's actually very easy to take the derivative. To find the limit using LHopital rules, but you must check for indeterminate form first. So always start by checking indeterminate form. If I replace 0 in there, replace 0 in there, 1 minus 1 over 0, which equals to 0 over 0. That's indeterminate. So by LHopital, we know that that equals to the limit as x goes to 0. Take the derivative of that, which is going to be minus negative sine over 2x. If you do direct substitution, you're going to get 0 over 0 again. So LHopital says, by LHopital, he said that take the derivative again. And so the limit as x approaches 0, the derivative of sine is going to be cosine. The derivative of 2x is going to be 2. Direct substitution, we get cosine of 0 over 2, and cosine of 0 is 1. So you have 1 over 2, and that is the limit of this. Okay, great job. I'm going to let you do number 4 by yourself, and then I'll do it in class so that you can check the work to make sure you did it right. Watch the second part of the video for the backside of this lesson.